So in this one, we have 4 graphs are shown, graph 1, 2, 3, 4. Which of the graphs shows the rate of a reaction on a vertical axis against the concentration for a zero order? So zero order, if we change the concentration, like if I just label them, if it was a rate here and a concentration here, which order is this? Second order, because if I have a rate here and a concentration, it's actually not a rate concentration graph.
Yeah, that's right.
Like this is not at all
Yeah, that's one is more of
concentration or a volume.
Yeah.
This is a rate concentration. When concentration is changing, rate does not change. This is a zero order. And this is a rate concentration. If you are increasing the concentration, rate is also increasing. So this is representing a first order. Double. So it means graph 4 is representing the first order with respect to rate concentration. So D will be the answer here. And which graph? Yeah. Oh, sorry, zero order. I thought first order. So zero order, then graph 3. I thought about, in my mind, I was thinking about first order. Then, which graph shows the rate of a reaction on a vertical axis plotted against the concentration on a horizontal for first order? So rate and concentration for first order. Rate of a reaction, and yeah, that is D, because we just discussed now. So this will be D. Question 11, again a common question in which a propanol iodine reaction is there in acidic condition, and it can also react in alkaline condition, which will result in a formation of a yellow precipitate triiodomethane reaction. Which method would be most suitable for this reaction? Look, iodine is there and it becomes hydrogen iodide. So which method is the most suitable? Colorimeter, if there is a color change, and timing how long the solution take to go cloudy, or quenching and titrating with an acid, or quenching and titrating with a starch.
So quenching will be necessary. It's
Quenching is necessary when you take a sample out. If you take a sample out, you have to quench, otherwise the concentration will change.
Do we take sample out in space?
No, if we are quenching, then we have to take a sample out. Now what? Look, the first one, if iodine, what is the color of iodine in aqueous? It is brown in color.
Okay.
Huh? Iodine in a low concentration is yellow. Normally, it's brown. No, it can be yellow, it's acceptable, but usually brown is there. Then it turned hydrogen iodide, so it turned colorless. So the color change will happen or occur. So color change will happen or occur.
So let's say there is the presence of an air, would that quenching be necessary in space?
If it was,
let's say this.
yeah, anyway, yeah, we can quench. Now, timing how long the solution takes cloudy. Solution will not become cloudy. Solution will become clear.
Yeah.
Then quench and titrate with acid. No, I should titrate with an alkali. If I'm quenching, I should titrate with an alkali because hydrogen iodide is an acidic.
Yeah.
So I can titrate with an alkali. And quench and titrate not with a starch solution. Which solution? Thiosulfate. Because iodine can react with a thiosulfate.
Yeah, so basically some solution won't react with anything. So
yeah.
What's the color of
Or no, starch is an indicator.
No, yeah, it's colored before reacting with iodine. Like what's the color of starch before reacting with iodine?
Before we add,
No, the color of starch before reacting with iodine.
Starch colorless solution is there, but it shows it's the color of specifically starch.
Okay.
If you cut a potato, what color do you see it for? It's like starch is.
It turns blue.
No. It's colorless. No color. You just add starch is white in color when it is appearing like you have a starch from different sources. That is white in color, solid. But if you make a solution, it will be a very cloudy situation or a,
Okay.
so colorless, you can also say that. The rate of a reaction is shown, as you can see, it is first order with respect to propanol and first order with respect to acid. In the first experiment, the initial pH is 1. What is the initial pH of a second? What we did? 2 experiment was carried out. In both experiment, the concentration of a propanol and iodine remained same, but the concentration of acid was changed. The initial rate of the first experiment was 3 times faster than the second experiment. In the first experiment, the initial pH was 1. What is the initial pH for the second experiment? Look, if initial rate is faster, what will happen to the hydrogen ion concentration? The hydrogen ion concentration, because we mentioned initial rate in the first experiment was 3 times faster than in the second experiment. So in the second experiment, the concentration of hydrogen decreases by 3. Decreases, not 3 times, decreases by 3.
I have to.
So we have the formula pH is equals to minus log of hydrogen ion concentration. If I need a hydrogen ion concentration, 10 raised to the power minus pH will be the hydrogen ion. So the first experiment, the pH is 1. So what is 10 raised to the power 1.5? 10 raised to the power minus 1.5.
So the pH of the second will be 3 times less than the first. And the H will be like the pH of the second equation would be 3 times less than the first.
No, first using a pH at 1.5, we'll find the hydrogen ion concentration.
Yeah.
And the hydrogen ion concentration will decrease.
Yeah, I mean, we can first get the pH by like dividing by 3, then from that.
No. The change in, because one is a log. The change in log and the change in pH is not the same. Like, it's not like if the pH decreases by 3, it's not like pH decreases by 3, log decrease, hydrogen ion concentration by 3. No, it's a log formula. So you cannot do like this. First, what you have to do, you have the formula that the pH is equals to minus log of hydrogen ion concentration. So you're finding the hydrogen ion concentration 10 raised to the power minus pH is a hydrogen ion concentration. So 10 raised to the power minus pH. What is minus 1.5? What is the answer? Can you say? 10 raised to the power minus 1.5. 0.0316. That is the hydrogen ion. But the second experiment, like first experiment was 3 times. So it means the second experiment it has divided by 3. So the new experiment it has divided by 3. The hydrogen ion. 3. By mistake I put. What's the answer here? So 0.0. 105. That is the new hydrogen ion concentration. Now what is the pH? So pH is equals to minus log of hydrogen ion concentration. 0.0105. So that is a new concentration of the solution. So you can see the change in the hydrogen ion concentration is not same as the change in the pH. pH only changes by the how many units? It's just 0.48 units.
So we get the H plus and the H plus H zone which is applied to the
equation. Yeah.
Yep. The rate, sir, is directly proportional to the H plus.
Yeah, rate is they mention here. The rate equation it shows that the rate is directly proportional to propanol and hydrogen ion both. Then a series of experiments were carried out to determine the rate constant, a graph of ln k and 1 over t, and the gradient was this. What is the activation energy? So how to do this? So we have the formula y is equals to mx plus c. So the gradient is minus E over R. If I need activation energy, we have negative m times r is equals to EA. So minus, what is the gradient? Gradient was minus 4670 and r is what? 8.31. We multiply them, we got EA. What's the answer for EA?
Negative 3A.
No, positive, because minus minus.
Oh, sorry. 3A. So then A.
And the unit, this was in joule. If we convert into kilojoules, we divide by 1000. Because this answer, as we took the gradient, our gradient was in, like this was in Kelvin. The gradient of a line was this. And this is joule. So it's not in kilojoule. So final answer will be in joule. And then you can convert into kilojoule by dividing with 1000. So it matches with A. Yeah. Option A. How many questions are there? 3 more. So when you simplify, the answer is in joule, but you divide by 1000. So that convert into kilojoules. Question 13. Solid vanadium 5 oxide catalyze the equilibrium as shown. Which statement is correct? So it is a heterogeneous catalyst. Heterogeneous catalyst trap the reactant on the surface and reduce the bond strength. Vanadium is a homogeneous catalyst. No.
Solid.
Yeah, they mention it is a solid and we have gases at the rear. Decreasing a pressure would increase the equilibrium yield of a sulfur trioxide. If I decrease the pressure, equilibrium will shift toward left-hand side, so it will decrease the yield, not increase. Increasing a surface area of a catalyst will increase the equilibrium yield of a sulfur trioxide.
Since it's convenience, the surface area increase
Yeah, and decrease the forward reaction is exothermic. Decreasing in temperature increase the equilibrium yield of sulfur trioxide. C and D looks. D is. See, increasing a surface area of a catalyst would increase the equilibrium yield. No, catalyst only affect the rate.
Oh yeah. Oh, yeah.
So decreasing a temperature because the forward reaction is exothermic. So if I decrease the temperature, it will shift the equilibrium towards side of less smooth.
Okay.
In which series does the standard molar entropy of a compound increases? First, it should be a solid will have the least, then liquid, then we have a gas, and then we will have the particles of the gas. Particles like sulfur dioxide and carbon dioxide, both are CO2 and SO2. Then we check the number of electrons, which contain the maximum number of electrons. Yeah, number, not share, like total number of electrons. Like sulfur is having 16 electrons, carbon is having 6 electrons.
So entropy depends on like because it's gas has plus like gas liquid and solid.
Yeah.
And
So what should be the answer?
the number of electrons increase the
Molar increases. So order, because we want a increasing entropy. So this is solid, this is liquid, these two are gases, but sulfur contain more electrons than carbon. That's why. Okay.
Yeah.
Because they were having the same number of particles, 2 oxygen and. Question 15. Experimental lattice energy values are there. Which of these compound expected to show the largest percentage difference in experiment? For a largest percentage difference, size of a positive ion should be small.
The
Charge should be high. So which positive ion? P with R. Like, no, it should be P with S. Because P will smaller positive and larger negative will cause more distortion. Okay. So that is, I guess, the last from section A. Yeah.
Yes, yes, it's correct.
Yeah. Now the last one is B. Yeah.